Hi everybody, I'm going to work on problem number 26, the lawnmower problem. So this is another example of a vector type problem, and most vectors means you got to work with the components. So when you push a lawnmower, you're pushing along the length of the handle, and that means you're pushing in two directions. One of them is into the ground and the other one is forward. So we'll start with a free body diagram that looks like this. Boom, there's our lawnmower. It's got a weight, force of gravity. We will draw a normal force that's pushing up. And they do say that there's a horizontal friction force that we'll have to calculate. Now, it's not super important exactly how you draw the force that the lawnmower is pushing at. You're pushing on the lawnmower, but it's basically something like this. You're applying a force that's pushing the lawnmower down. So that's basically adding to how hard you're pushing into the ground, that vertical force, and it's also going to act horizontally. So there is going to be some horizontal component, and there's this vertical component. The way we work it out is that trigonometry piece. So there's my free body diagram. If I want to work out my horizontal friction force, I need to figure out a couple things. The first and most important piece is this right here. You should know constant speed means no acceleration. That also means if acceleration is 0, mass times acceleration is also 0. So net force, and I'll just write up the sum of our forces in the x direction. So when I do this, x, when I do this, I'm looking for basically the list. So there's the force of friction that's going the opposite direction of my applied force in the x. I know that this is 0 because of the acceleration bit. So now, looking simply at the math, 0 equals something plus something. You know that these two are going to be equal and opposite. I just have to find out the applied force in the x. What we're dealing with a 45-degree angle and a force of 88. So that means we're pushing with a force of 88 newtons at 45 degrees. Here's my angle. This is my opposite side. So if I want to know what this horizontal component is, I'm using the opposite, and that is a sine function. That's going to tell us our force applied in the x. All right. If we can get force applied in the x, friction is going to be equal and opposite. So that's that component. Should be able to get force of friction once you know the applied force in the x because they're balanced. The next part's normal force, and we're actually doing that part the same way. So for part C, we care about the sum of our forces in the y, and we're dealing with a force of gravity that's going to pull it down, and we are dealing with a normal force, and we are dealing with a force applied in the y. Force of gravity is mass times gravity. Force applied in the y, again, we're looking at this triangle, 45 degrees, 88. This time we're looking for the adjacent side. It'll look like this. For those of you math people, you know that equilateral triangle, if it's 45, 45, 90, I did not draw that correctly. It should be something more like this, because both of these sides are going to be the same length. So whatever you got here should be the same value here, and that's going to be how much force you're pushing down with the lawnmower. I don't think I'm giving away any secrets when I tell you that it's not accelerating into the ground either. So sum of my forces is 0. I've got the mass of the lawnmower times gravity. the normal force, this is what I'm solving for. And then I've just explained how to come up with the forces in the y. All right, what else we got here? So up to part D, what force must the person exert on the lawnmower to accelerate it from rest to 1.5 in 2.5 seconds? Okay, so let's change this 0 to whatever the new mass times acceleration is. You've got an acceleration right here. So let's add a little bit to that acceleration. We'll assume that the friction is going to stay the same, and you'll have to figure out what that force applied in the x is going to be. We'll just worry about doing it in the x. Okay, so good luck with 26. Thank you.